Hello. So for these problems, what we're looking for is finding a final amount in a word problem on exponential growth or decay. And every single one of these problems is going to follow the same sort of pattern. You're going to have some sort of initial amount, and then that amount is either going to increase or decrease over the years. And there's going to be some sort of percentage that they're going to increase or decrease. This one, the initial amount is 22,000. The percent is 35%, and our time is 5 years. There is one basic formula that you need to know for all of these problems that deal with an exponential growth or decay, and when we're looking for that final amount. That formula is the final amount is equal to the initial amount times 1 minus the rate, the percentage that changes every year, raised to the power of the number of years. All right? So I put F for final amount, A for initial amount, R for the rate, that's the annual rate of increase or decrease, and then T for the number of years. Now, that minus is if it's a decrease every year, and it will be up. So it's decrease is going to be a minus. If it's increase, then that's going to be a plus. All right? And the reason why this is considered an exponential is because it's obviously based on the number of years, which is there in the exponent position. If we look at this problem exactly, it says a car is purchased for $22,000. After each year, the resale value decreases by 35%. What will the resale value be after 5 years? All right, well, they go ahead and give us all the initial information we need right there. So this is our initial amount. A, it's a decrease, so that's going to be a minus 35%. That's going to be our R value of 0.35, and 5 years, that's our time. Literally going to take all of those, plug them into the formula, and figure it out. So our final amount, the amount that this is worth after 5 years, is 22,000. 1 minus R, so 1 minus 0.35 raised to the power of 5. All right? You literally type that into Desmos, and you get 2,553. Let me show you real quick why that is. Raised to the 5th power, 2,552.6999. So when or 639 rather. So if we round this to the nearest dollar, the 2,552.6 is going to round up to 2,553. Next problem. A city has a population of 350,000 people. That's going to be our initial amount. Suppose that each year the population grows, so that's going to indicate a plus, by 3.75%. So R is equal to, turn it into a percent by dividing by 100. So 0.0375. What will the population be after 12 years? So T is equal to 12. Literally the same thing as our formula right here. So our final amount is equal to initial amount, 350,000, times 1 plus, in this case, since it's growing, 0.0375 raised to the power of 12. That's it. Just plug in that formula. When you do, you should get something around 544,409 people. Again, we can slide over to Desmos and literally just change those numbers there. So instead of, we'll just change this, 35, 123, sorry, 35, 350,000. times the quantity, 1 plus 0.0375, and then raise that to the power of 12. See if we can get 544,409.016, round to the nearest, and that's going to be nearest whole number, 544,409. All right, for our next problem, this looks like some sort of compound interest one. So a principal, that's our initial amount of $3,800, so $3,800, is invested at 6.25%, so that would be R is equal to 0.0625. Remember, divide that by 100 to get the decimal equivalent. Compounded annually, so that means it's growing. This is going to be a plus. How much will the investment be worth after 11 years? That's our T value. So final amount is equal to initial amount, 3,800, times 1 plus 0.0625, and then raised to the 11th power. Notice this is compounded annually. In my next video, I'll show you how to deal with what happens when the money is compounded, that is, the interest rate is applied quarterly or monthly, and so on and so forth. It's just one very, very slight change to the formula, but for this one, notice compounded annually, so once every year, which is why it kind of falls into this category of problems. You plug that in, come up with the answer. If you want to try it on your own, the answer is $7,403. All right, for our last problem, it still falls into the exact same category, but it's going to look different in what it seems to be asking. See, this says the half-life of a radioactive isotope is the time it takes for a quantity of the isotope to be reduced by half of its initial mass. Starting with 165 grams of radioactive isotope, how much will be left after 3 half-lives? If you haven't talked about this in your science classes yet, the idea is that you have some types of matter that are somewhat unstable, and literally, like, the protons just kind of shoot off over time, almost like they evaporate. But anyway, so let's say you've got, 10 pounds of this uranium isotope or whatever it happens to be. If its half-life is, say, 50 years, that would mean after 50 years, you've got 5 pounds. After, that's LBS. After another 50 years, you would have 2.5 pounds. And so on and so forth. And so every 50 years, every half-life, it decreases by half. So our formula here is not really changed at all. We're decreasing by 50%. So the R value is equal to 0.50. That was 50%. It's decreasing by 50% every half-life. So because it's decreasing, that's going to be a minus situation. Now, and then since instead of having years, like after every 2 years, and this is our half-life is we want 3 half-lives. That's going to be our T value. So that's the number of times it's compounded. So T is equal to 3, and our initial amount, 165 grams. That's the A. It's the exact same formula. The final amount is equal to the initial amount, 165, times 1 minus 0.5 raised to the power of 3. Plug that in. According to the answer key, you will get 21 grams. Let's double check that over here on Desmos. So 165 times 1 minus 0.5 raised to the power of 3. 20.625, if we round this to the nearest whole number, 21. And that's what you got right there. Alright, so with all of these problems, my final recommendation would just to be a reality check to see is the final amount more or less than your initial amount, and then see if that makes sense. In this case, we see that we have some isotope, it's decreasing, and so our final amount should be less than the initial amount, and in fact it is. We started with 165 and we're ending up with 21. Good luck with these problems.